Okay, we'll see next question, sixth problem of this structure applied maths. Question number 6. There is wedge is given. Let's say this is 60 degrees. Yeah, 60 degrees wedge, smooth wedge kept on the horizontal floor or table. Mass is M. Here another mass there. This is mass M. Here also mass M. As shown the figure, smooth wedge is mass M with an isosceles triangle. The cross section is an isosceles triangle. Is placed on a smooth table. A particle of M mass kept lower point here. The wedge is moving with the acceleration of 3g. Show that the particle will ascend. Particle will ascend meaning go up. That's called ascending. Ascending order like that. Particle go up. We have to show that particle will ascend up along the inclined plane, right? So 3g wedge is moving 3g acceleration. So they say g is the usual under gravity acceleration due to gravity. Okay, so I take a general form, instant part of the motion. I take somewhere here, particle we see come here, is it possible? The particle comes, is it possible or not? We'll find that. The particle can take somewhere here or can be ascend somewhere here on the incline. We'll see is it correct or incorrect. Then if possible, the problem is solvable. So here 60 degrees. So if I show the force diagram, this is mg. And it's all the same as mg. And the reactions there. This is structure type wedge, not a big essay problem. Usually the essay also we have the big wedge problem. The structure type, perpendicular reaction I say R. Next about the acceleration. I assume the wedge is moving this side 3g. Wedge is moving this side 3g acceleration. So if I use the letters E called earth, E for earth, and W for wedge. Next P for particle. P for particle. Then you have to show here the, we call this one relative acceleration. So let acceleration of the wedge relative to earth, I say moving this direction, 3g, the direction 3g, and I take this is moving up, small f, that's moving up small f, that is acceleration of the particle relative to wedge, that is upwards, the inclined plane upward that. So I need to find relative to earth what is the acceleration of the particle. Then we can apply as usual F equal ma application. Therefore, acceleration of the particle relative to earth. How this one? APE can be shown as relative to the principal. Acceleration of P what W plus acceleration of WE. Okay, so what is PW downwards F plus WE this side 3G. So every wedge problem you should show this. There will be 5 marks in the scheme, minimum 5 marks for that part. Therefore, according to the earth reference, particle has 3 components of the acceleration. One is downwards and this direction. So WP that is upwards. Okay, therefore this also has a component 3g, right? That's all. So my answer method is show that particle ascend upwards. So I want to find, I am going to show what about the small f answer. Is it positive or negative? If that value comes negative, it won't go up. It comes that retardation method. So main issue to find the small f is a greater than 0 or less than 0. So apply f equal ma. Apply f equal ma. For that we apply for the particle first. Particle, apply that it's moving upwards. So if I apply upwards, apply particle f equal ma upwards, where the forces act upwards, all both down, mg down, therefore mg this here 60, here 30, mg cos 30 minus, right, mg cos 30 minus mg cos 30, only that force component of the weight, no any other force for the particle, because r is perpendicular. If you resolve, it become r cos 90, vanishes, you can't take, right? It's equal, mass is m, but the acceleration of the particle, upwards, two components, small f upwards, here 60, then here 60, 3g cos 60 is it, minus 3g cos 60, minus 3g cos 60, minus 3g cos 60, right? Therefore here see cancel, cancel, so here what is that, minus g, so what is cos 30 root 3 by 2, cos 30 root 3 by 2, here small f, minus 3g cos 60 is half, cos 60 half. So my target to find the small f value in terms of that fg also there. So to can call that, therefore f equal, take this side and simplify, take the g out, then 3 by 2, here minus root 3 by 2, okay, take the 2 also out, so f equal g by 2, and what, 3 minus square root 3, 3 minus square root 3. Now you tell comparing, by comparing, this is positive, 3 is bigger than root 3, 3 is bigger than root 3, therefore this is a positive answer, plus answer, plus. Then you can write the statement, therefore small f is an acceleration, therefore particle can move up, particle can ascend up along the inclined plane of the wedge. That's the answer. I hope you try with me and comparing with your answer and check that, correct it. Okay, next question number. Previous video I shown 5 problems. Here I complete the remaining rest of the parts. Those are newcomers, stop and see my previous video, and I publish already what this structure model applied maths. Already I complete 2 pure mathematics structure type. Okay, see next question, that is impulsive tension, one of the structure model, or every papers we have such a impulsive tension problem, like collision, direct collision, separately impulse along the string. So the diagram shown, a pulley and a light inextensible string passes over, and the two extreme of the string particles are tight. One particle is, they say, small m mass, and the other one is 3m mass. Okay, As shown in the figure, two particles of masses 3m and m are tied to the two extremes of the string, light inextensible string, which is passes through a fixed smooth pulley. Initially, the heavier particle lie on the floor, on the ground. Other one is like suspend freely like this. So what they say now, when the system is at rest, the mass m, this mass m, raised by a height h. This small m, they take a height h and freely dropped. This is ascend or took a height h and freely or gently released. Then what happened? If you take up, the string becomes slack. If you take up, the string becomes slack and drop freely. It becomes under gravity motion. So again, it's fall height h. If we took up a height h and drop it, and it will fall a height h. Using under gravity motion, we can find the speed or velocity on that instant, right? Then what happened hereafter? Suddenly, when it's that fall down, suddenly there is a blow. That like a vibration. Blow, we call blow. That according to that blow, that string changes velocity. The mass suddenly changes velocity. Initially one velocity, suddenly after blow, it becomes another velocity. So velocity changes, but still the mass is m. So what happened? Velocity changes with the mass constant. Final velocity minus initial is called momentum. That's called momentum. So therefore there is a momentum. As a result, this string has an impulse I or J. That's the idea of impulsive problem, right? So what I explained now, I can show by diagram form also, by another adjoining a draw the second case of this, but they mention here, what they described here. Say this. This is okay. Now the string somewhere here. I see somewhere here. Now the string is slack, not a tied string now, the slack part. This is H. They said a particle, the small m, raised by small h and gently released. So it's this thing there after h happened. So now what happened? I show that also. So diagrammally I can explain not only for this question, for any future problem you can think these ideas. And gently released. Now I say the speed is u, right? Gently released, speed is u. This is height. So, and after releasing a small height, once again drop freely under gravity motion, the same instant there's a blow, like a small vibration along the string. As a result, speed becomes v later. First I complete this u, right? So we can use the ordinary under gravity formula to find the initially 0 height u. So we can apply the v square equal u square plus 2fs formula. So I can show here. Apply v square equal u square plus 2fs formula. This formula to when drop. So final velocity here u, right? U square initially 0, here 0 and plus 2gh. Therefore u equals square root of 2gh. Square root of 2gh, right? This is initial time is 0. Here after send a height of h, then drop freely. Now after this, a sudden blow happen in the string, along the string. As a result, suddenly velocity become change. That's I mentioned this diagram. I say v. I say there is v, right? After getting u, suddenly instant of the blow, there is velocity changes. I said v. The same string, therefore it comes up, right? V. It rise up v, right? This is v. They have the same string, therefore velocities are equal. So why it becomes V? A small blow, instant blow happens in the string that we call J or I. So I mark that I. Same string, therefore also I. This is velocity, I said, is moving up, velocity V. So question is what? Show that the impulse on the string, they're asking the J problem, right? So diagrammatically I shown this the initial case after dropped and final this happened. Then we use this, is okay. Now we apply the I equal delta mv formula. I equal impulse equal to change in momentum, right? So apply I equal delta mv formula. I equal delta mv formula for this. If I come to small m, first we apply for small m. I equal delta mv. So small m particle I apply I upwards. I direction I apply. So upwards, that is I equal change in momentum. What is in mass into what is that? Final velocity minus initial velocity, change in momentum. Final minus initial, right? Change in momentum, that's equal to final minus initial. So I apply both V are downwards. Other time I can say I apply downwards, I apply down, no matter whatever I apply down, therefore minus I, yeah? minus I. Final velocity V minus initial velocity U, okay? So I equal delta mv, that means change in momentum. This is the equation for the first particle. So I want to find the V value. So I can simplify, take divide here, minus I over m equal V minus U. You know the U answer. We know the U answer, right? Okay, keep this first equation. Keep it first equation. Now we apply the same I equal delta mv for the second 3m mass particle. For this I can apply the downwards V or upward, no matter wherever, right? So now we apply for 3m. For 3m particle, I apply that formula, direction of the I, upwards. So what the answer? I equal delta mv. I for I. Mass is 3m. What is change in velocity mean? Final minus initial. What is final? V. Final is V, right? Minus, what is initial? That is your diagram. The original problem, see, that's the diagram, initial state or initial stage. That is off, rest. So 0. Therefore, I equal 3mb. I equal 3mb. I say my second equation. I equal 3mb. Now put this V answer here. Otherwise, what is V equal? V equal I over 3m. V equal I over 3m, right? Question is find the impulse. Answer is provided 3mu over 4. Okay. So now I connect the both equation. So I say second equation, or connect the 1 and 2. So 1 comma 2 is minus I over m equal V for what? I over 3m minus u. So you know the u answer already we mentioned, right? Now you subject the I simplify. If I use it, I take the I out, 1 over 3m plus 1 over m equal to u. So here LCM is, there is 3, there are 4, right? I 4 over 3m into u. Therefore I equal 3mu over 4. I equal 3mu over 4. You know what is u? They said u equals square root of 2gh. So it's the problem, impulsive tension idea, right? Okay, we'll see next question, problem 8. Question number 8. ABCD is a rectangle given there. The simple statics problem, coplanar forces. ABCD is a rectangle such that AB 6, AB equals 6 and BC is 8. Okay, BC is 8 and H is a point on AD. AH is given, how the AH is 6, or somewhere I can take somewhere here. This is 6, therefore here 2, that is 2, right? Total 8. The forces F1 act CB, F1 act along CB, and force 5 act where CA, no? Along CA, diagonal along CA 5 act, and 6 root 10 act where HC 6 square root 10, so Newton forces act downwards, and next one F2 act where CD F2 act along CD, and finally F3 act AB, right, downwards. That's all. The question is, if the system is in equilibrium, find the F1 value, F2 value. So I hope you complete successfully. Check with my answers. F1, F2, F3, calculate those values. So what happened here, if equilibrium means total horizontal component 0, vertical component 0. If you take any moments about any point, that also 0. So you need 3 equations to solve, then can be calculated. You have very first, if I say theta, this is theta. So when you resolve, you need this angle. What is this, tan theta or sin theta? You know the sign. Here 6, here 8. So sin theta. So height become 10. Pythagoras apply. 6, 8 mean here 10, right? So what is sin theta? 6 over 10. Otherwise 3 over 5. So what is cos theta? Cos theta 8 over 10, otherwise 4 over 5, right? It also we need to apply this theta. Also if I mention this one, if I say alpha, this is alpha, here 2, here 6, so you know that also, right? Here 2, here 6, here 2, here 6, so what is this HC? What is HC value? Pythagoras. Here 2, here 6 means square root of here 4 plus 36, square root of 40. Okay, therefore if you want sin alpha, what is sin alpha? What is sin alpha? Opposite is 2, hypotenuse square root 40. Okay, what is cos alpha? Cos alpha is what? Adjacent 6 over square root 40. So before go to the simplification, you can find this value because we need to apply in the later part of this question. Okay, now we will find properly, you think, for systems in equilibrium, right? So if I take moments about C, if I take the full system moments about C, what happened? 5 goes through C, won't come. This goes through C, won't come. F2, all 3 here, F1, all the forces are vanishes except the F3. That's the equilibrium idea, right? If you take about C moments, all the forces are vanishes because force is available, distance is 0. Therefore easily you can find the F3. So you can write sentence, for system take moments about C. Take moments about C. So if I write C, take moments about C, like this. I write this direction, but the moment means force into distance. So force is F3, force is F3, distance 8, okay, equal to 0. Therefore F3 0. Check your answer. F3 null, no F3, the F3 is 0, okay. Next we find F1 and F2 by resolving, also easy. So next I resolve horizontally. Resolve horizontally. Resolve horizontally. What are the forces? Here F1. Here F1 and plus 5 cos theta. Okay, plus 5 cos theta. And F2 vertical won't come, right? Here 5 cos theta. And this one, how this? 6 root 10. Here cos alpha. 6 root 10. Here cos alpha. Therefore here sin alpha. But arrow that side. I am resolving this side. Therefore minus. Minus 6 root 2 root 10 sin alpha. 6 root 10 sin alpha, right? And what? 3 forces comes. So algebraic addition of along horizontal or vertical equal to 0 because system is in equilibrium. Therefore equal to 0. So here you can find the F1 answer. Is it by applying everything? You can find the F1 answer. So F1 plus 5. What is cos theta? Cos theta also, that is 4 over 5. 4 over 5 minus 6 square root 10. What is sin alpha? 2 over square root 40. Okay, equal to 0. This 5 cancel. Here you know, cut this 4, cut this 10, cut this 10. Here 40 means 4, therefore square root 4 is 2. Square root 4 is 2. 2 cancel, right? Here minus 6. Here what? Plus 4. Therefore is it 2 Newton. F1 equal 2 Newton. F1 equal 2 Newton, right? F1 equal 2 Newton. Okay, so next we resolve vertically upwards. Resolve vertically upwards. See what happened. Resolve vertically upwards. Then you can't take the F1 because F1 in horizontal. But is upward, F2 up. F3 come down, minus F3, which is 0, right? Next word, this is 5 cos theta, then upward 5 sin theta. And this is downward 6 root 2 cos alpha, minus downward, right? Minus 6 root 10 cos alpha equal to 0. Algebraic summation is 0. Then we apply and find the answers. So F2 equal what? F2. This is 0. F3 is 0. Plus 5 sin theta 3 over 5, right? 3 over 5 minus 6 square root 10. What is cos alpha? 6 over root 40 equal to 0. Now we simplify this, get the answer. Here 5 cancel 2. What is sin theta? Sin theta. What is sin theta? 3 over 5. 3 over 5. Sin theta 3 over 5. Then only 5 cancel like earlier. It becomes 2 here, 4 here, 3, then 18. So simplify. Is it 15? F2 equal 15. All are Newton's value. Newton, right? F2 equal 15 Newton. A simple question. Well balanced for the structure type question. They ask one static problem, Lami's theorem, or triangle force diagrams, or something like this also. Okay, now question number 9. There is statistics. See, for two data sets, question number 9, each of size 5. Each of size 5 means 5 numbers, 5 marks. That's the meaning, right? Their variants are given 4 and 5. Two different sets are there. if I say set x, set y, two different sets, right? Here 5 numbers, here also 5 numbers, like that, both occasion 5 numbers in the set x and the set y, right? So they said the variance are given. You know the idea of statistics, usually very first thing mean value, find the mean, next find the mean deviation, next find the standard deviation, next go to the variance, right? Variance idea. So if I show some relation between the variance and standard deviation is square root of the variance. Standard deviation is square root of the variance, right? That's a variance we call like this symbol, sigma. Therefore, two set of numbers are given. For example, I mark those x and y. So one set, the variance given 4, other set variance given as 5. So I can mark like that. Variance means standard deviation square. This is variance of the first set. I took as x value. First set is x, right? That is given as 4. And next one, if I mark as a y, its variance they marked 5. This is two data here given, right? Further given, their corresponding mean, average. So what is mean? Adding all the 5 numbers divide by 5. Adding all the 5 numbers divide by 5, we call the mean. So if I mark that knowledge, x bar we call the mean. How they found the x bar? Add all the 5 numbers, divide by 5. There is a sigma notation also for a mean value. It's like this, sigma xi over 5. This is 2. This is 2. Therefore, you can just think of O-level mathematics. If the mean is given, you can find the total. So what is all the addition of the first set of number? 10. 5 times 2, 10, right? Therefore, here, sigma xi equal to 10. Sigma xi equal to 10. The same as the other y set of numbers. They said their mean is 4. Therefore, I say y bar, that is, I mark as a y bar. That's equal to how? Adding all the y values and divide by 5. This is therefore 4. Let's say the second set numbers, mean is, average is 4. Therefore, in this case, we cross multiple, sigma yi is 20. Sigma yi equal 20. Now the question is, find the variance of the combined set. Find the variance of the combined set, right? Therefore, you need some formula to answer successfully this problem. How to calculate the variance of the first set. They are given the answer. Answer is provided. What is the formula to find the variance of the first set? So remember, this is the formula. Sigma x square equal 1 over, that means totally, sigma xi square minus x bar. Sigma xi square minus x bar square, this divide by n. The general formula, the relation between the mean and the variance. This is called the variance. There is x bar is the mean. This is square of the each values. Divide by, here n is 5. N means number of marks or number of set. The value of the set, that is 5. So in this case, you know, this is 4. This is 4. And x bar is known 10. Then you can find this value. The combined, finally we have the, if I write that also, what is combined variance? There's a formula for combined variance. Combined variance formula is this: sigma xi square sigma xi square plus sigma yi square, okay, over the sum of the both occasion, the marks, sum of the values, these things, minus x bar plus y bar all by 2 all things square. Remember this formula, this is we use for the combined variance. Here x bar means one set average, mean value. Y bar means other set mean value. So both addition, average of that both and square it. This is separate, that is separate, right? So in this case, sigma xi square mean all the simple values squaring and adding. There are 5 numbers, for example, think 1, 2, 3, 4, 5. But therefore, what is sigma xi square mean? 1 square plus 2 square plus 3 square plus 4 square plus 5 square. That's the meaning of that, whatever 4, 5 numbers or whatever numbers. This formula is the combined variance. Therefore, before come to this, you will find all this and come here, substitute, get the answer is 10. N1 plus N2 is 10 here. N1 5 numbers, N2 also 5 numbers, 5 plus 5, 10. Okay. That's why I use this formula. So this is given 4 equals sigma xi square over 5 minus x bar is 10. X bar, for the first x bar given 2, right? So 2 square. Therefore 4, 8, 40. Sigma xi square is 40, right? Sigma xi square is 40. Sigma xi square is 40. Sigma xi square is 40. Then similar fashion come to the sigma y square. If I show same formula here, sigma, that means variance of the other set, square is sigma yi square over n minus y bar square, minus y bar square, right? Now we apply, what is sigma? This is 5, this 7, this is 5, equal sigma yi square, n is 5, minus what is y bar? Y bar is 4, is it? 4 square. So simplify a 16, take this side 21, multiple 5, that's 105, right? Therefore, sigma yi square is 105. That's all. If you know this everything only, you can calculate the combined variance. If you know the variance, its square root is the standard deviation. Okay, now apply this formula. So write this formula, combined variance. Combined variance equal to sigma xi square plus sigma yi square over n1 plus n2 minus x bar plus y bar over 2 all things square. Therefore now you have to substitute everything. What is sigma xi square? 40. Next one 105 over sum of the 2 marks 10, and that side x bar. What is x bar? Average of the first occasion 2, ne? 2 plus the other occasion y bar, that is 4, okay, over 2 square. One x bar is 2 and 1 y bar is 4. So it is 639. So simplify and get that, then you have answer. To simplify, check the answer, become 11 over 2, 5.5. Check that, 11 over 2 or 5.5. Is the idea of solving, simplifying this combined variance. Here, both such a information you can find this, right? One of the important question for any future paper, such things for the special structure type. So if you work check or if you idea correctly, noted what how I mentioned, important for future problem. I will show many, expect me if you keep with me, I can show many structure type or essay type, probability, statistic, all the lessons. Okay, right, this last question, problem number 10. There's a probability part. A, B, C are three events, right? Three events such as, there's a probability A given C, they said greater than probability B given C. This is conditional probability, conditional idea, probability of A given C greater than probability of B given C. So we'll see what happened, what this inequality gives us as a result. Final part is what? So if we know conditional probability formula or definition, we can continue the part. So I show how to write this one. Probability of A given C means how? That is probability of A intersect C over probability of C. Right? That is conditional probability definition. And greater than your probability of B intersect C over probability of C. Okay, is the conditional probability definition. So both sides PC cancel. I can say probability of A intersect C greater than probability of B intersect C, right? This is, we take one method, one answer, one inequality for one data. Also they provide next one, probability of A given C complement C dash, given C dash greater than probability B given C dash. Now we'll see what happens if I use this inequality for a conditional part. The same idea, write this, what the meaning? What the meaning, show the same method. This can be shown probability of A intersect C dash over probability of C dash. Okay, that's greater than this one, probability of B intersect C dash over probability of C dash. So like earlier, see, this both cancel. We have a remaining part, probability of A intersect C dash greater than probability of B intersect C dash. I say my second inequality. Now the problem is show that PA greater than PB. Show that PA greater than PB. So at the moment here no PA, you also no PB, but no C in the answer. We have the answer already. Therefore the idea here, after both same side of the inequality, same shape of the inequality, so I can subtract or I can add. Now I add the both, right? Add these two inequality. 1 plus 2. Add these two inequality. One is probability of A intersect C plus the other one is probability A intersect C dash. Okay, other side greater than probability of B intersect C plus probability of B intersect C dash. Okay, at the both. Okay. Now you need some logical, that means sets language, knowledge of the sets. See that probability of A intersect C. How that part? What is A intersect C dash? See, I explain you by using the Venn diagram. See, Venn diagram. here A, here C. Where that part, your primary work of Venn diagram, C dash cut by A, this one. Is it A only part? No, A only. Therefore, can I write this shaded part in a different manner? Completely but A, complete A, subtract the middle part. Is it okay? Complete A, subtract the middle part. So probability of A, subtract the middle part, A intersect C, greater than, okay, now this probability of B intersect C, same method, think that B intersect C dash, I say here B, so without C, B cuts, same ideas like earlier. So how I can show this shaded part, completely B, take the middle portion out, therefore probability of B minus probability of B intersect C, minus probability of B intersect C, is it? Now see, this cancel, therefore PA greater than, here cancel PB. It's a very useful question, very important question for the future problems. There are such like many inequality there in probabilities is one of the answers shown, right? Okay, well, so I hope you understood this my 10 question applied previous video. I have answered 5 question, here rest of the 5. So practice, keep in touch. We can take high achievement for any other exams preparations. Next time I publish in a different model paper, you can work it, and like this I will show the solutions. You can discuss with your own knowledge by correcting with me my answers.